Hello, this is Mr. Montgomery. In this video, we're going to be looking at some example problems dealing with electric circuits. We're going to look at a series circuit and a parallel circuit. This video is designed for my Physical Science 1 lab students that are taking lab online to help you with the calculations you're going to be doing as part of that lab. This first example we're going to look at for electric circuits is a series circuit. And so in this circuit, we have a 10-volt battery right here connected with 3 resistors, 10 ohms, 20 ohms, 30 ohms. Shown here 2 different ways with your simulator, the way you can kind of view it there, the actual pieces of your batteries and your resistors, or the more conventional circuit diagram where your resistors are these little zigzag lines and your battery up here is a short line for the negative terminal and a long line for the positive terminal. All right, I know this is a series circuit because there's only one pathway that this current, the conventional current, would flow from the positive terminal through these resistors and back here to the negative terminal again. Okay, so there's only one pathway. The same current must flow through all 3 resistors. First question is, let's calculate the equivalent or the total resistance for this circuit. Well, when resistors are in series, what we want to do is take all those resistors, however many there are, and add them all together. So for this series circuit, we want to add up these values, the 10, the 20, and the 30 ohms. And so if I add 10 plus 20 plus 30, I'm going to get a total resistance of 60 ohms. Now, how much current is flowing out of this battery and through this circuit? Well, Ohm's law tells us that voltage equals the current I times the resistance R. And I want to solve for the current. So that means the voltage divided by the resistance. Divide both of these equations, divide both sides by R right here to get R to cancel out. And so I'm looking for the total current. I want to use the total voltage, which is the battery's 10 volts, divided by the total resistance we just solved for here. So those 10 volts divided by my 60 ohms. All right, so 10 divided by 60 gives me a current of 0.17 amps. It was 0.166 repeating, but 0.17 amps of current flowing out of this battery and flowing through all 3 of those resistors. All right, now let's look at a parallel circuit. Okay? Parallel circuit, same battery, same 3 resistors, but now they're connected in a different way. I know this is a parallel circuit because I have multiple pathways. The current might take this pathway that takes it through the 10 ohm resistor. Some of the current might take this pathway that takes it through the 20 ohm resistor. And then the third option is some of the current might take this third pathway that takes it through the 30 ohm resistor. So parallel circuit, the key is there's multiple pathways for the current to travel through. And that means these different resistors are going to have different amounts of current flowing through them. But they're all going to have a voltage of 10 volts because it's kind of like they're their only thing. You got 10 volts here. Well, that 10 volts can go to the 30 ohm resistor, or the 10 volts can go to the 20, or the 10 volts can go to the 10. But let's find their total resistance. It's a little more difficult finding total resistance in a parallel circuit. What we're going to do here is we're going to add 1 over each resistance. So I need to do 1 over 10 plus 1 over 20 plus 1 over 30. And if I had more of them, I could add those together as well. All right, so I need to add these fractions. 1 over 10 plus 1 over 20 plus 1 over 30. All right, now this is not my final answer, but it says 0.183, and that 3 is continuing to repeat. That equals 1 over resistance. So I need to take the inverse of this. I'm going to use my inverse button right here on my calculator to take the inverse of that previous answer and tell me that this total resistance is 5.45 ohms. The other option, instead of using this inverse button on my calculator, I could take this and say, okay, well, this is equivalent to 1 divided by 0.183. Okay, the inverse is taking this thing, taking its reciprocal by flipping it upside down. All right, now, what's the total current in this parallel circuit? Okay, we're going to do this the same way we did the last one. The Ohm's law tells me voltage is current times resistance. So the current is going to equal the voltage divided by the resistance. We still have a 10-volt battery, but now we have a total resistance of 5.45 ohms. And so 10 divided by 5.45 gives me a current of 1.83 amps. All right, but that is the total current. That's how much is coming here out of this battery itself, coming here and reaching this point before some of that current goes to the first resistor, some of it goes to the second, some of it goes to the third. Okay? But the total coming out of the battery is what we just solved for. So I hope those example problems give you a good idea of the calculations and the problem types that you're going to be solving and working out after you perform your experiment or as you perform your experiment. And as always, if you need more help, then feel free to reach out to me, and y'all have a great day.